Professor Hansson, thank you very much for agreeing to this interview. So you have attended the Nobel Prize in Physics press conference on 3 occasions. And so may I ask when your term began and when it ended?
You should have asked me that. I think I started 14 and ended 23 or perhaps 13 to 22. I'm not entirely sure, but we have a 9-year maximum, and which I think is good. You shouldn't have more influence than that. So, but roughly, yes.
And you were the committee chair in 2021. So is the chair of the Nobel Physics Committee rotated annually, and is the chair appointed by the Royal Swedish Academy of Science? And how are the committee members who attend the press conference each year selected?
Well, the one who sits there on the podium is the chairman always, plus the one that is going to give the presentation, and that is one that is in the field, an expert in the field. So that's what decides who the 3 people are. And the committee is elected, I think, by the full academy, but it's the proposal from the physics class of the academy, and that proposal goes through. So in physics, it's basically the physicists who decide.
So it's the proposal that who will get the Nobel Prize?
That's it's a long procedure, and it's actually described in some detail on the homepage. But roughly speaking, what happens is that we send out lots of, where we ask people to come with proposals, and we get in lots of proposals, and then we send out or the committee sends out to experts in the field, and they typically get some of these nominations, and we say we want a review of this area, here you have some typical nominations, and then they write reports and send back to us. And this is something that can go on for many years, So when there is a prize, especially a prize like this that is for experiments that were done in the 80s, then this has been on the table, as you might imagine, of course, for a long time. And there has been many expert reports, etc. And then usually what happens is that someone in the committee sort of summarizes these things. And then it's discussions in the committee, and then you come to a proposal, and that proposal is discussed in the class of physics. And then finally it goes to the academy and for a final vote, which was today with this year's prize. So that's how it works.
So for the topic is first, we said that the topic is that first stage that you determine it, and then to find the scientist. For example, we know a kind of matter physics or high energy or quantum, and then you find which topic.
Yes. I mean, the important thing is the physics.
Yes.
You have to find out what are the really big discoveries or big inventions. Now, Alfred Nobel, as you presumably know, he wrote in his will that it should have been during the past year, and as you know, that's not what had to go away from that. But it should be really big discoveries or inventions. That's very important. And then it's of course sometimes very easy to find who should get the prize, because it's perhaps only one or only two or only three. But sometimes there are many, and then it's of course more tricky. Imagine the big particle physics experiments, it's 3,000 people on the paper.
Yes. And what happened when there are so many
authors on the list?
Then you have to try to figure out, who are if you have decided that this is important enough that it should be a Nobel Prize, then it's up to the committee to come up with maximally 3 names. And that's not simple, but
can you imagine?
You have to do it.
Yes. Like, can I? So, for example, like 2016, that is a Nobel Prize for this BKT transition and hold on, and then that time you explain with the bread and this donuts. So, because we mentioned that this 2D phase transition is BKT, but that time is gave K and T, but not B, but Holden.
Yeah, you know, these are exactly the tricky things, and I could give you the many other examples. What I cannot do is to tell you how the discussion went in the committee, because that's secret for 50 years. So that I cannot talk
50
about.
Years.
50 years.
So after 50 years,
after 50 years, you open the document, and then you can see the reports and see how arguments are given for this and this and that. So for historians, you know, if you're interested in the thing that happened 75, 76, then you can go and see. Yeah.
Okay.
That's interesting. And speaking of the committee, and what were your specific responsibilities when you served as a committee member and as the chair?
The chair is chairing the meetings, but all committee members have the same kind of influence. Of course, you gain more influence when you sit for many more years because you gain experience, but that's another thing. Being a chair rotates, at least in the physics committee. I think it's a little bit different in other committees, but in physics it rotates. And your main responsibility is to learn about the topics that is coming up for the prize. That are there are always a list of possible prizes, and those you have to learn about that, and that is sort of fun work, because you have to learn about something which is not your own field. So even though it's in a sense an administrative job, but still it's rewarding because you have to learn about science and discuss science. And it's important that everybody in the committee sort of learn about a wide range of things, because otherwise, there might be someone who's an expert in this expert, but you want to understand what the experts say. So that's what you do. And also, something I always stress in these discussions is that it's not a bunch of Swedish professors. Used to be only men. Now it's also women, which is very good. That just sits and come up with a Nobel Prize and say, oh, should we take this guy or should we take her? No, it's this very serious procedure with getting lots of nomination, lots of reports, summary reports and discussion. So it's really anchored among the best experts in the world as well as we can. That should be stressed.
Yeah.
And also, your first appearance at this Nobel Physics Prize announcement was in 2016, and Yanliang also talked about that. And you, as he said, you have a cinnamon bun, a bagel, and a pretzel to explain the concept of topology. And that is a moment left a strong impression to the public. So how did you come up with this approach to introduce the Nobel-winning work like this size?
Well, I mean, it worked out very well. It was like my 5 minutes of fame, as people talk about. So using the difference between a ball and a ring of some kind, for swimming, or a bagel or something, is sort of standard illustration of surfaces with different topology. And, I don't know I think it was who came up with the pretzel as having 2 holes in it. But of course, the thing that made it sell was that it was things that you could eat. So I could have it in a lunch bag. So that was a lucky coincidence.
Then the question is that when you bought it, because you have to know the answer, and then you prepare, and then you bought it. You have to bought in the morning.
Well, it's lots of rehearsal for these kind of things. So there were staff who bought the stuff.
And can I ask what happened to the bread lately?
I don't know. Perhaps we ate it.
Okay.
I don't remember.
And so, did you prepare the presentation slides by yourself, or also the staff will help you?
No, I mean, I prepared. Yes, I prepare the slides, of course, but you get comments because, as I said, you have dress rehearsals for these kinds of things. But yes, I think I prepared it with some help. Yeah.
This morning we saw that it's really that people will come to the building and then to vote directly. So which means that it's not decided yet in the morning, but the slides should be prepared after voting.
Yeah, I think you shouldn't ask more.
Okay.
We touched the line already. Yeah.
Well, I think you can figure out for yourself the situation.
And so my other question is also about the Nobel Prize. So what are your views on the trend of Nobel Prize laureates in physics receiving the award at an increasingly older age, and what factors do you believe are contributing to this phenomenon?
Yeah, that's a tricky question, of course. It's not always true. Sometimes there are, really things that you can say immediately that this is a big breakthrough, like before my time, but the discovery of high temperature superconductivity.
Yes, yes.
During my time, it was the detection of the gravity wave. Now, those people were not that young either because they had been working on it forever and ever, So when it comes to big experiments, yes, then it can be that lead times is so long that the people that are in the experiments, become old before it's done. Then it's other things like perhaps this year's prize, where the experiment was done a long time ago, but the significance of what they did becomes clear as time goes on, and that is quite common actually. So I think that is what drives this thing, and of course it's always nice if it's younger people.
What you will say to this younger generation, or if we should have some male set that we should hold something, or some suggestion to the younger scientists?
Well, I mean, what can you say? I mean, you're a physicist. You might get interested in physics because of Nobel Prizes or something else, but you cannot continue to do physics because I'm going to get the Nobel Prize. To continue to do physics seriously, you must be driven by curiosity. You have to figure out how it works, either by measuring or like we are making calculations. So I don't think that's a problem for physics today. What I think, it's not a problem really, but when I went into physics, which is now we are talking about the early 70s, late 60s, early 70s. When I went into physics, it was very clear that the most challenging thing was elementary particle physicists. And I was actually a theoretical elementary particle physicist in the beginning of my career because that was the thing that was really challenging. And then I switched to condensed matter because that looks perhaps even more challenging. But the point is that now you have so many things, the AI revolution, computer science, you have neuroscience of various kinds, neurobiology. So there are many, many fields which are exceedingly intellectually challenging. So physics has to compete with all those things, and that means that you presumably perhaps gets fewer of the really good people than we got sometimes. But I'm not sure. This is just my speculation.
Yeah, and also now it's more difficult than before that just change the word by a pencil.
Pardon?
You change the word by a pencil, just write an equation and then it changes the word. now it's like you have to find structure or the direction will sub, and then...
Yeah, but in some areas of physics, there are basic challenges. The area I used to work on, quantum chromodynamics, QCD, it's still not understood in a deep way how you form protons and neutrons out of quarks and gluons. You can see that works by making extensive numerical simulations on supercomputers. Yes, that you can do. So we are convinced that this theory is correct. But the goal to get something beautiful, something elegant, like the quantum mechanical understanding of the hydrogen atom, or the helium atom, on that conceptual level, that's still missing. That's just one of these things. In classical physics, to get a real understanding of turbulence, you presumably know that understanding the Navier-Stokes equation is one of the millennium problems. So there are.
Yeah.
And that's my last question is, so you've met so many Nobel Prize laureates, and do you think they have some common characters or something that...
Except being very good physicists, do you mean?
Yes.
No, not really. They are very, very individual. But they are all great physicists. But yes, no, they are very, very...
Okay.